you from on the fidget.
See those? You ever put water on a hot skillet?
Yeah.
It's kind of like that. Now, this stuff is really cold. In fact, it's probably pretty close to negative 196 degrees Celsius. But for some reason, guess this table is super, super hot. At least compared to the liquid nitrogen, right? But the liquid nitrogen doesn't just automatically disappear. Any idea why it doesn't disappear? Hey, what happens to the liquid nitrogen when it hits the table? Turns into a gas, right? And just so happens that gases are really good insulators. And so what's happening is those little drops, the bottom of it turns into a gas, and then it kind of floats on the gas. And so the gas kind of keeps it from getting to the table too quick. So if I wanted to, I mean, I can take my hand and put it in there. And kind of, as long as I don't leave it in there for a long period of time, what happens is when I take my hand and I put it in there, well, what happens to liquid nitrogen? It turns into a gas because they heat it up, right? Well, that gas kind of protects my hand for a little while. Now, if I stuck it in there and just kept it in there and kept it in there and kept it in there, then I'd turn into the robot in T2, and that wouldn't be necessarily a good thing here. But I just have some demonstrations that we're going to kind of go through here. First of all, it's pretty obvious. I went and got these yesterday afternoon. There is a student that was probably here like 12 years ago, maybe 10 years ago. I better make it a little, it wasn't that long. She's now an engineer at Mustang Engineering and so forth, and she also played tennis for me. But her parents own a kind of an oil well machine shop, and they make valves and stuff. And they have to use this stuff to basically, they put a valve inside of a metal pipe. Well, what they'll do is they'll take that valve and they'll put it in liquid nitrogen. Well, guess what happens when you put metal, you put something into liquid nitrogen? Hardens. What else might happen to it? It contracts. It actually gets smaller. And so what they do is they put that thing in the pipe, and then when it warms up, it expands, and you've got a really good seal there. And that's one of the uses. And that's kind of, and they do other things too. Also, they clean out pipes. They shoot it through there and stuff. But anyway, so they're nice enough to give it to us. And I've had this since last night, or yesterday afternoon, around 3 o'clock is when I went to go pick it up. And this thing here, it's one heck of a thermos. Because it's kept this stuff at negative 196 all the way through the night into the day. So it's like a high-tech thermos. The thing that this does the exact same thing. What does a thermos do? Keeps things hot and cold, right? So we're obviously having to keep the cold stuff in there away from what? The hot stuff out of there. Hey, do you remember from chemistry, what are ways that we can transfer heat or transfer thermal energy?
Conduction, radiation, convection.
Conduction. Okay, all I'll ask is first period you got to keep them up and radiate. Okay, so the way this bottle is built, I don't know if you can see it. But this thing here, it's a glass bottle. This thing here is just protection. This is a glass bottle, and guess why they make that the bottle out of glass? Why would you use glass? Yeah, it's a what? Yeah, it contains the temperature. What type of material is glass? It's an insulator. Okay, so that's the number one reason. It's a really, really good insulator. The next thing it is, and so that kind of keeps conduction from trying to happen. The next thing it is actually a double glass container where inside of here, they've actually vacuumed this out, so there's nothing in there. So you have a vacuum. So that vacuum is also going to keep conduction from trying to happen. Okay. The other thing is, what color do you notice this is? I don't know if you can see it. That's that, but what's the color here? Silver. Any idea why it's silver? It reflects the light. And so that keeps radiation from happening. If you have this silver, once radiation tries to get in here, it is more so reflected back. So all of these things make this a thermos where we can keep this stuff at a really low temperature. Because something like a styrofoam is a really good insulator, but after a while, and it actually stays in for a while, it'll finally go away. But this does one heck of a job with it. So the fact that I can take my hand and kind of cool some stuff here while we got some things in here.
How cold is this runner?
Negative 196. Wow. Sorry. So basically what's happening is I'm taking my fingers in there and splattering it on out here. We can take something like our rose here. It's going to be kind of tough for me to do because it's kind of small, but we take a rose, and definitely this stuff if I freeze it, we take this nice looking rose and it changes what it is. So obviously you freeze it, it changes its properties and stuff like that. If I get an A, there's the A. Keep everything freezing in there. That's some other things. Sure, I won't do that yet. That may be too much. Hey, so Adam. Let's see if this is that so hot?
I can go boil it again.